So, Matz is going to do his thing here and tell us about all the stuff about Ruby and why he's here. We are going to keep this open for questions at a later stage. So if you have questions, please keep them ready. I'll help you out. I'm going to be your host for the rest of the day, or at least part of the day. I'm Gautam Rege, and if you all have any concerns about anything during the conference, please feel free to contact me or Sidhu here. Last but not the least, before Matz gets started, is Satish. Is Satish here? I think. So Satish here had to actually head back to Pune. All right, it's a very uncanny thing, but at the start of the conference, we usually don't give a thanks to him. But he had to head back home because of a family emergency. So he's the reason why all the things at ETT work smoothly and everyone is able to get a good night's sleep and come here and find out everything is in order. Okay? So please remember to tweet Satish about it and thank him for all his hard work. Matz, are you ready?
Yeah.
All right. Matz, stage is yours.
Am I coming to the next RubyConfIndia? Probably, I will. So, yep. Yeah, I'm back. Yeah, I like visiting foreign countries and meeting people all over the world, and then talk about the Ruby, and talk about the programming, and talk about their lives, related to the programming. So, the programming is quite interesting activity. So, that kind of things made me interested for a long time. So today, I'm going to talk about what is software made of. So that is inspired by the old children's song titled, What Are Little Boys Made Of? The what are little boys made of? What are little boys made of? Snips and snails and the puppy dog's tails, that's what little boys are made of. What are little girls made of? What are little girls made of? Sugar and spice and all things nice, that's what little girls made of. But I'm not going to talk about little boys and girls, so yeah, they're adorable though. But I'm going to talk about software. So what is software made of? So what is the ingredients of software, like spice, sugar and spice for girls? Sorry for the minor trouble. I'm sorry. So what are the ingredients of the software? First ingredient, in my opinion, is the hardware. It's kind of the contradicting, but the hardware can exist with the software, like this hardware shop. But no software can exist without hardware, basically. It's not 100% true, just because when I was a child, I wrote a program on my notebook with my pencil. So it was a software, it was a program, but it didn't need hardware to exist. It probably requires the hardware computer to run, but it didn't require the hardware to exist. But that's kind of the silly story. But mostly the no software can exist without hardware is the mostly true. So my first computer that I programmed in is this one. This one is something called pocket computer, and a very, very teeny computer, which was first published in 1980, which is 37 years ago. Whoa. It has 4-bit CPU. Have you ever seen the 4-bit CPU? And it runs BASIC. And it only has the memory to store the 1,400 steps, basically lines of code. And the basic interpreter for this teeny computer is very, very small and limited. all variable names have one length. So that means we can have only 26 global. So it was so poor computer. But it was 37 years ago. The computer has been evolving so fast. It has now faster CPU and more memory, more storage, and wider bandwidth. For example, the computer I was using when I started Ruby in 1993, so it was the computer called engineering workstation. So which is the news workstation, which is come from the Sony company, which probably sold in Japan and US and very limited regions. And it had the Motorola 68020 60 megahertz CPU and 8 megabytes of memory. What's wrong? It's coming back? Oh. And it costed about 20,000 US dollars. Whoa. And the last year, I bought a new laptop, Lenovo ThinkPad T460 S, which has the Core i7 CPU, which is the 2.6 gigahertz of clocks, and 20 gigabytes of memory, and 1 terabyte of the SSD. And it costed only 2,000 US dollars. That means the CPU is comparing by clock speed, so 325 times faster. And the memory is the 2,500 times bigger. And the storage is the 6,410 times bigger. And then the cost is 1/10. So the new computers are so fast. The problem is we have suffering illusions. For example, the Moore's law. Do you know Moore's law, of course? So the number of the transistors in LSI doubles every 18 months. But the problem is the number of transistors is getting bigger and bigger consistently still, but the clock speed of the CPU is not getting faster. And then by this graph, green line is the number of transistors, and the deep blue line is the speed of clocks. So the last several years, this is an old graph, and the year 2010, but from 2001, 2002, so the clock speed was saturated. That means, so in the past, we get more speed by buying new computers without modifying any software. So buying new computers makes our software faster. That's easy way. But these days, that things does not happen any longer. So we have multi-cores. So instead of having faster, bigger CPU, we are having many computers, many CPUs in a computer. That means that it's the end of free lunch. So we software developer enjoys the faster computers just by upgrading the computer. But these days, to make our software faster, so we have to use concurrency, threads, processes, many things. And unfortunately, concurrency is hard. So correct concurrent software is kind of like a nightmare, quite difficult. So this is the first and second illusions. Instead of one fast, big computer, we have many teeny computers inside a machine. So the next illusion is the caches. We have, when we program, so we have some kind of the mind image of the variables nearly equals to memory, right? But what's wrong? What's wrong? The real memory model is in the CPU we have registers and memory. It means the stack and heap. This is the old model of the CPU. But the situation has changed. We have caches in between the register and memory, which is caches are faster memory. But the problem is the cache is very fast, but the size is very limited. So when data is on the cache, it is quite fast. But when the data is on the memory, it is quite slow. How slow? Okay, the registers are, the L1 caches with 4 times slower, and L2 caches the 10 times slower. The L3 caches the 40 times at minimum slower, and memory is 100 times slower than accessing register, and the storage like SSD hard drive is at least 20 million times slower than accessing register. So you have to 20 million clocks to get data from storage. Not to shady connections. So the storage is 20 million times slower. So the developers need to fight with those kind of illusions. So we have to know about the hardware detail sometimes. The hardware is the first ingredient. The next ingredient is the languages. So we write software. We write software in programming languages. The language language is consisted by grammar and vocabulary, like Hindi, like English, like Japanese, the grammar and the vocabulary. Each language are different. Programming languages are the same. We call them, programming language are consisted with the syntax and grammar. I hate that. The syntax and library, the language, programming language, the way to express your idea, and the communication between humans, us, and machines, computers. The language, the tools to form your idea. So you have very vague idea of what software is going to be written. And then the language is a tool to form your idea concretely. And then the language is the tool to boost your brain. That means, okay, so for example, so you have some ideas, but having, say, object-oriented programming, so you can form your ideas into the object-oriented way, which is much way organized than your vague idea in your mind. So in the linguistic, so we have the Sapir-Whorf hypothesis, which is fundamentally the human thoughts are influenced by spoken language. Like when I speak Japanese, my characters, my ideas, my thought are influenced by the Japanese language. When I speak in English, my characters, my behavior is influenced by English language. I don't speak any Indian language, unfortunately, but if I do, my idea will be influenced from those languages. So that is Sapir-Whorf hypothesis. And then, so that rule, that theory can be applied to the programming language as well. So your idea, your mind, your behavior, your programs, your result will be influenced by the programming language you use to write your software. It almost, I'm sorry. So, okay, keep going. That means the language matters in your programs. So no matter which language, that's okay, no matter which language you use in your next programs. But the point is you have to care about your programs, your program language. So language influences human thought more than you thought. The language matters. The evolution of programming language. Programming language was born, I don't know, 60, 70 years ago. The first programming language was Fortran. But it was, at the beginning, it was as terrible as BASIC. There's no recursion, no local variables, no nothing, you know. It's much better than writing some binary code. But it's, for them, the people in the 60, 70 years ago, it was quite wonderful. But from our viewpoint, it was quite terrible. So the programming language comes after, and after. So each programming language evolves. Each programming language were better than the previous ones. Each programming language is more abstract than the previous ones and more concise. The program is getting more and more concise. And that means less code. That means easier to write and easier to read, except for some cryptic languages. And that leads to productivity. So that makes you more productive. So the abstraction is the key of the evolution of the programming languages. So it hides internal detail. That means that the abstraction provides illusion, like hardware did. But the programming language try to create illusion for you. So you don't have to worry about the caches, these abstractions. But at the same time, so you don't have to worry about the inside. So the developers sometimes need to play with illusions. So illusions that make you productive, and an illusion that make you consume less brain power. The productivity matters, just because by being productive, so you can solve most of your problem. For example, productivity make you work less, so you can spend more time on your family, your hobby, whatever you want. So, and then productivity makes you earn more money. So the productivity could bring you success. So, and by having money, work, success, so you can do virtually anything. So the productivity matters. The language matters and the productivity matters. So the last ingredient of software is developer community. You mean community is quite difficult to define, but basically it's a gathering of programmers or some people interested in programming language like Ruby. So, no, it won't go. So the human things, computers, machines don't program, at least yet. But we humans have to program. So the point is, we have our strength and we have our weakness. We don't program, at least yet. We are not machines. So what's the difference between machines and humans? So it's the heart and the desire. So machines do not desire anything. They don't have feeling. So machines don't want anything. But we do. So we program because we want something. We want something better, better productivity, better feeling, better life. So we program because we want something. So, and the machines do not have passions, but we keep programming because we have passions. For example, so I started developing Ruby 1993. So it was 24 years has passed. 24 years has passed. So there's very few software that is keep developed for more than 20 years. There's a few ones. Linux is one of them. The Ruby is one of them. Python or Java or some other programs survived more than 20 years. But the reason behind this survival is the passion. Oh, anger, not anger. Passion. So, the anger. So, we sometimes program because we get angry at something. Have you ever heard of the three virtues of programmers? So, that is laziness and impatient and hubris. The laziness means the angry feeling that you feel when you see machines are lazy. So we want to be lazy, but we don't want machines to be lazy. So that's laziness. Or the impatient is similar things. And then hubris is the angry when you feel you have complaint from users of your software. So you try to create complete software. So that means that these three things leads to angry you feel when you develop the software. So angry sometimes leads you to create better software. So these kind of things is the good virtue. unlike these bad words. But they are good virtue of great programmers. What's wrong with it? No. Anyway, so we have weakness. So our ability is very limited. So our memory is weak. We forget many things. So we sometimes forget what we ate last night or something. Our memory is so weak. And our ability to recognize pretty limited. So let's imagine your slide on the screen. Okay, we have weak will, so we have to be fight with our weakness. Okay, that's yeah. Okay. So our weakness is the reason that we need illusions. That illusions that language and abstraction could provide. So to fight with those kind of our weakness, so we have to have that illusions, and along with community. So we are weak, so we can work together to make great software. So by working teams or a community or collaboration, so we make great software. So the collaboration is the key of the development success and the motivation behind the great software. So I started Ruby in '93. I told you before. So that is my independent effort. So one person working on the very early stage of Ruby. But after releasing it to the internet, so the few hundred people joined our community. We set up the mailing list, and more than 200 people joined to the mailing list in 2 weeks. So the people, the members of that mailing list, tried Ruby and found bugs and even fixed bugs and proposed many things. So that these input from the community made Ruby better programming language. So I created Ruby. I throw the first snowball, but the people, community in Japan, all over the world, so people from everywhere form their effort into the Ruby. So the Ruby is not the individual effort result, but the actually is the result from the collaboration work. And then if people didn't have any interest in my new programming language, so I would gradually be bored, and then I probably would gradually give up Ruby. So the Ruby will disappear. So the community made Ruby possible. That means that we need community to create the great software, great services. So the community and the collaboration is the last and greatest ingredient of software. So in summary, so what is software made of? So hardware, languages, and the developers community. That is what is software made of. So the hardware is pretty important. So we have faster computer, but more and more complex the computer. So we have to work with. But these things are too complex to handle. So we have the tools, operating systems, the programming language to hide these inside detail. So that is kind of illusion, but that illusion makes you more productive. And then you can fight with complexity of your software, your hardware, and your world. The software complexity is brought by the reflecting the complexity of the real world. The human society is so complex, and then software complexity is the result of that complexity. So the language matters. So the programming language is pretty important. That's why I care about the programming language. I made Ruby because I wanted to create software. For most of the people, including you guys, the programming language is given. Programming language is given. So you don't design Java, you don't design PHP or even Ruby, but I just wanted to make decision on design of programming language, or I wanted to design my own programming language. That is the ultimate goal of myself. But think about that. You write software on top of Ruby and probably on Rails. But the writing software is kind of process of designing API for your application. And or probably some kind of that domain-specific language for your applications. So at least part of your software development is kind of design of domain-specific language of your application. So that means the language and the design of the language matters not only to language designer like myself, but to you as well. So you have to design your own programming language on top of existing programming language and framework. The last ingredient of the great software is community. So you have to work well with the community. Your software users, your clients, and yourself is part of the one community. So their ideas are very valuable. Of course, as a lead designer of the product, you might need to reject many of proposals, ideas. But still, these ideas and the people behind these ideas are pretty important to create great software. That things is the green, okay, again, hardware, languages, and community. These three ingredients are very key component of your software and your software creation. So that's most of my talk. So I want to tell you a few more things about the future. The Ruby 3. So I talked about the Ruby 3 last year, and the situation hasn't changed much. But at least we are working on concurrency because the hardware, the key component, key ingredient of the software, the hardware is evolved to multi-core. So we have to address that kind of change. So the Ruby 3 will have better concurrency. And then we have more users. And no one complains about the faster Ruby. So we are going to make Ruby faster. And then we keep making Ruby faster 5 to 10% each year. But so we are going to make some kind of drastic performance improvement, like by introducing something like JET or some kind of optimization. So in addition, we are going to help programmers, like having some kind of static analysis, so helping you to find bugs earlier, hopefully in compile time. So that we are working on that kind of things. We are having research on these kind of things. So we are discussing with the research people, computer science research people, and we are talking with the developers and engineers in, say, some kind of big companies like IBM, Oracle, and then we are by aggregating these kind of good resource and good ideas, we are making Ruby even better programming language in near future. So some say Ruby is dead, but Ruby is a programming language. It does not live from the first time. But the software dies when it stopped evolving. And we, the community, we core developers, promise you that we keep making Ruby improving. So we keep moving forward. That's the promise I'm going to make. And that means Ruby will never die. Thank you.
Thank you so much, Matz. We have some time for questions. Questions? All right. Anyone? Questions? So, Matz, I had a quick question there.
Yeah.
There's like you've spoken properly about the future of Ruby.
Mm-hmm.
What about how the community here can actually help out in a way to give you the right feedback or the right experiences about using Ruby?
Well, we core developers are mostly C programmers. So we program Ruby, but we program very small Ruby programs, usually. So we need input from the experience of viewers. So example, you might feel some inconvenience in programming the real-world Ruby or Ruby on Rails application. So that kind of input is very valuable for us. And if you find bugs in Ruby, or if you find any the trouble in Ruby, that would be valuable too. And if you submit the pull request to Ruby, that would be great. But or maybe your improvement ideas, suggestions to our reference manuals and documents or anything would be great. And probably the biggest contribution to the community is the telling the people around you that Ruby is great. That would be a great contribution to the community.
Matz, one question from me.
Yes.
So generally, every time you've spoken, you've always mentioned some other language that's interesting to you. So among the stuff that's come out recently, the newest, least known languages, which do you think are the most interesting that are worth learning something from?
Well, my recent favorite language, one of my recent favorite language is Elixir, which is designed by Joseph Alim, who is a Rails committer. And then on top of the Erlang virtual machine, which is, which addresses that kind of the concurrency problems. So we see another one is the programming language named Stream, which is kind of the stream-based programming language, which is designed by myself. It's the toy programming language I worked for as a hobby for last 2 years, but it is not for the real world usage. But it is quite interesting to play with. So you can find it in the GitHub Matz/Stream STREEM Stream programming language, which is kind of interesting. And what else? Yeah, we have tons of other programming languages out there, and then there are many programming languages has brilliant ideas, and I like them to read about that.
Hi, Matz. My question is regarding kind of strictness in Ruby's type system. So my question is, have you considered adding, say, gradual typing? And the follow-up is, what is your personal opinion on programming by contract, so enforcing, say, preconditions on method input and method output?
Okay. The first question is the compile time type systems. About some dynamic programming language introduced some kind of the type notation to their language. For example, the JavaScript by adding type annotation to the JavaScript, the Microsoft creates TypeScript. And then the Python 3 recently introduced the type hints. And then also I don't like them just because by adding type annotation, so we hinders dark typing, so which is the very flexible, then very good point of Ruby. By hindering those dark typing, so we lose our power, at least partly. So I'm not going to add that kind of things. So instead, so we are investigating some kind of type inferencing, the very the global type inferencing. And in addition, yeah, the type inferencing is very difficult to be sound and complete. But right now we don't have any compile time type check. So at least we could find, say, 50%, or hopefully 80% of the bugs. That would be great. In addition, so it's only my vague idea yet, but adding some kind of YARD documentation or something like that, so we can retrieve some kind of the type contract from the documentation. So, and we apply that kind of the declaration into the source code. So by adding that kind of things, we can have some kind of the contract or the type checking in compile time. So the design by contract things is very useful for many cases. But right now I'm thinking about it should be implemented by gems, like a kind of the assertion that could be turned on and off by compile time switch or something like that.
Okay, thank you, Matz.
Thank you, and sorry for the troubles.
And don't worry, we have the experts here who can stitch in the presentation into the video when we publish it. Yes. So our next speaker is a good friend, Shashank Date. He's been in Pune and now he's in Kansas. And he's been Ruby Midwest organizer, and he has got a lot of interesting ideas to share with us. Shashank, I believe we are not going to get the Ethernet connection on your Raspberry Pi.
That's fine.
All right. So, over to Shashank.
Thank you. Am I on now? Okay. Yeah, power connection.
Okay. We didn't need to mention to anyone that the hashtag is RubyConfIndia, which is great. We are seeing the tweets coming in. Please keep the tweets going. If anyone faces any internet problems, let me know. We have the hotel staff ready to help out with all these things.